All right, so in the last module, we explored the related phenomena of electricity and magnetism. Today, we're going to be looking at electricity in more detail, specifically electric circuits. This is, once again, the idea that electrons uh, flow in one direction in a closed loop, and that can yield some usable energy that we can extract and turn into other forms of energy like heat or light or motion, etc. So to begin this, I actually want to start looking at a system that is a little bit more tangible, easier to see, easier to imagine, easier to work with. Instead of looking at little electrons flowing, why don't we imagine water flowing? So here I have a system of flowing water. Here's my water up high in a water tower. So because the water has been elevated off of the ground, it's high off the ground, it has some energy stored into it, right? I can think about this water as if it is a reservoir of energy because it has been stored off the ground. It has gravitational potential energies. If I give that water a path to flow, water will always seek to flow from areas of high potential to areas of low potential. So you guys know this, it's pretty much common sense. Water will flow downhill. It will flow from high elevation to low elevation. In fact, everything will do that, right? If you raise a ball off the ground, it will always fall down. This is because systems in nature always seek the lowest potential energy arrangement. They always want to spontaneously arrange themselves for the lowest potential energy possible. In other words, high potential energy is not stable. Nature does not like it. It wants to get rid of that potential energy, convert it to other forms, and seek a lower potential energy arrangement. Um, you guys know that that's going to be water on the ground. So if I let this water do what it wants to do, if I open up a valve and let it flow, give it a path to flow down, it's going to flow down, and ultimately all the water will drain out to have a low potential. But as it does so, as it goes from regions of high potential to low potential, high elevation to low elevation, I can take advantage of that change in energy, and I can extract some of that energy out to do useful work. So let's imagine this. I give the water a path to flow through. It's going to flow. We call that a current. The water's moving. Um, this water wheel represents me extracting some useful, usable energy. Sometimes we call that work, energy that's used to do something specific. Work has a very specific meaning in physics. It is the transfer of energy, how much energy is being transferred. So here I have potential energy being converted to what type of energy? Kinetic, right? Because the water's moving, and then that kinetic energy will be transferred to a different object, to this water wheel, which I can use to do multiple things. Turn some turbines, generate electricity maybe. I can use it to grind wheat, things like that. So I can extract useful energy from this flowing water. And as the water flows down, it eventually settles here at a region of low potential. What if I wanted to get the water back up to a high potential to keep this going? What am I going to have to do? Well, I'm going to have to maybe set up a water pump or something like that. You guys know I'm a professional artist. I've told you that multiple times. So here's my lovely, beautiful water pump. And that water pump is basically going to take water and pump it from a low potential to a high potential. And now I have a continuous closed loop of flowing water. The water gets pumped up to a region where it has high potential energy, and then it's allowed to flow down to regions of low potential. Um, and I am extracting some of that energy out to do useful work. And in order to keep the cycle going, I have got to pump the water back up to high potential, let it flow, extract energy, and we go around and around and around. So why am I talking about water flowing in this way? Well, it turns out that electricity, electrons flowing, works the exact same way. So here you can see on the right side of my diagram, it's just another simplified diagram of water flowing. The water pump does what? It gives the water high amounts of potential energy. Here I'm calling it pressure. So the water has high pressure. In other words, it has a high motivation to flow. Water will always flow downhill from high potential to low potential, or it will also always flow from regions of high pressure to low pressure. So the pump is pushing the water up, creating high pressure. The water is motivated to flow down to the lower pressure regions or low potential regions. And as it flows around, I can extract some of that useful energy out with my water wheel. When it comes here, it's back to low pressure, and the pump will pump it back up again. Guess what? Electrons flowing through wire in a closed loop works the exact same way. Remember, in the last videos, we said that electricity has got to flow in a closed loop and it has to have a power source. Here my battery is doing the exact same thing as the water pump did. It is giving those electrons motivation to flow. It is pushing them. It's giving them high potential, high pressure. We call it voltage. We'll define that in a little bit. So because the battery is providing voltage, potential energy, or pressure to the electrons are going to flow around. I call that a current. And just like the water, where I extracted useful energy from the water with the water wheel, I can extract useful energy from those flowing electrons. So in this example, it's a fan. It could be a toaster. It could be your phone charging. It could be your laptop, whatever. So this device is extracting useful energy. And then by the time the electrons get down here, they're now at a low voltage. They're at low potential energy. They have low pressure, low motivation to flow. They're now sluggish, so to speak. Just like the water down here. It flowed from regions of high potential, high pressure, down to low potential or low pressure. And then the water pump pumps them back up to complete the cycle. That's exactly what the battery does. This is why electricity has to be a closed loop, a closed circuit. Let's imagine that my wire was broken right here. If the wire is broken right here, there's no way for those electrons to get back to the battery and get pumped back up, so no electrons will flow at all. Now, this is where the analogy breaks down a little bit. If your pipe is broken right here, water will still flow. It's just all going to leak out at the point at which your pipe is busted. Electrons are a little bit different. If there is no way for them to get back, to get pumped back up to a high potential, they're not going to flow in the first place. So electrons always require a closed loop to flow through a circuit. We call this a circuit because it's a loop, an electrical circuit. It must be a closed loop, and it must always have these parts. The battery to provide potential energy, a way for the current, for the electrons to flow, and then something to extract that useful energy, to transform that energy into another form. So this is what we're going to explore, the parts of this electrical circuit, and it's helpful to think about it like flowing water. Here's a great way of thinking about it. Let's imagine these little spheres are electrons. I know they have little pluses on them, but don't get confused. There's a reason for that. I'm not going to get into it. Let's imagine these are electrons. You guys know that when electrons flow in one direction in a closed loop, that's electricity. This is an electrical circuit, a diagram of an electrical circuit. So here's my battery. It works just like a pump. It uses energy to pump up these electrons and give them higher amounts of potential energy. So because they're elevated, they have the potential to cause a change to flow back down. This R1 and R2, imagine these are like water wheels. As the electrons flow, these are going to spin, and I can extract some energy out of them. So energy is leaving here, energy is leaving here. So I'm extracting useful energy as the electrons flow down, and now they're back to zero potential. And the battery pumps them back up. They have potential energy. They flow down. As they flow down, they turn my water wheels. I extract that useful energy, and they're going to continue flowing in this closed loop until the battery itself runs out of energy to keep pumping them. So this is exactly how electrical circuits work.